Hello everyone, again with me, Faye, and in this particular video, we're gonna exercise a little bit about procedure. Okay, procedure. Let's dive to the first question about money denomination. Okay, so you guys already familiar with this question about denomination in your ALPRO1. I think you guys always get this question. So what we want to do is to we will have one input about our value of money, and what we want to do is how many 10,000 bills we have, how many 2,000 bills we have, how many 1,000 bills we have. That's the programs wants us to do. Okay, so we have denomination 10,000, 2,000, and 1,000, and we have starting value, which is in our example we have 6,000 and 77,000. 70,000 you can break it down to become 10,000 bills, 2,000 bills, and 1,000 bills. Okay, so how the code will do? I think whole thing, but what we do is just to make a separate function. In your Golang, you will see function, but in our pseudocode, we use procedure. Okay, so we make a procedure. As you can see, the question wants us to change three values, okay, which is K10, K2, and K1. We want to change it according to our algorithm. In a function, you actually can returns more than one value, but so far in our learning and our studying, we use a single return value, okay? So if you guys want to change multiple values in your function, in this context, we say it's procedure, you need to use a procedure to change multiple value. Okay, so what we do, we have three value to change, okay, which is K10, K2, K1. It's a pointer, which is an in-out parameters, okay? As you can see, it doesn't have any return value. This is a procedure, okay? So this is the simple logic we're gonna use. Money, division 10,000, and the rest of it, you will division it by 2,000, and the rest of every money, you will divide it by 1,000. This is our code. As you can see, what I do in my main, only scan for getting inputs from user, and after that we do output and call the procedure. That's what we do in our main program. Okay, so that's for number one. The key thing here is the pointer, which is we're gonna modify the value of K10, K2, and K1 according to our algorithm. And as you can see, our money parameters, focus on line 13, our money parameters is not a pointer, okay? It's just a simple in parameters, not an in-out parameters, because we don't need to change the value inside the procedure. That's what I do in this question. Okay, let's go to the next question. We go to the second question about temperature. So again, you guys already familiar with this question. It wants to, let me give you a simple explanation. It wants to convert the Celsius value into Reaumur, Fahrenheit, and Kelvin. Okay, that's what the program wants us to do. So same as a denomination, it's actually really it's just the same question, but different formula. Okay, to convert to Hammer, this is your formula. To convert to Fahrenheit, to convert to Kelvin. But as you can see, we have in parameters, and we have three in-out parameters. Okay, and maybe in printf we modify it a little bit so it looks more neat. Okay, as you can see, input, call the procedure, and after that do outputs. That's what we do in our main only. Okay, Let's jump to the third question, and yes, that's our last question, reordering two numbers. So, what's this question wants us to do? Okay, so we have a 5, 4, 2, 7, 19, 10. If you see the outputs, it always outputting the first number become the small number. So if you see in this question, it already said the initial state and final state. Initial state is about integer a and b. Final state is if a is smaller than b. Okay, no, if a larger than b, that you need to swap it. That's how the procedures wants us to do. So maybe you see this 5, 4, okay, just output 4, 5. So if you have a variable xy, just outputting yx. No, you need to uh, swap the value a and b if the a is larger. That's what I do. Reordering. Simple swapping algorithm. Okay, we have temp as b. If a is larger than b, b becomes a becomes 10. Okay, you guys already know this. But in the question, it doesn't say it about when the inputs will stop. Okay, so that's why we see the input and output example. As you can see, when it's a 6, 6, it stop. It doesn't have any output. So that's what I do. Okay. So why I use repeat until like this? Because when it's 6, 6, it's stop. And I think repeat until is really suitable for this program because it more clean. And as you can see, when the last it checking in last thing, okay, after you inputting on the first. So if it's 6, 6, it stop completely. If you guys doesn't believe me, let's go run this code. We go to exercises, and after that we go reordering to numbers. Okay. So if I have 4, 5, okay, 5, 4, 6, 7, 7, 6, 6, 6. It stopped. No output. That's why I use repeat until for this question. Okay, so that's our exercise for procedure. As usual, you have this tracing, but I cannot code this, and it's hard to write it down. But this is important. Tracing is always important. Is you That's why you use pseudocode again and again, I say. So your brain is can compile a program before you write it. Not just trying code and error change like that. No. But you hopefully to be coding correct from the start. That's why you need to do this tracing. But I cannot give you the answer for this. So that's about our procedure exercise. I always say that I always try to expand this question. I always try to put some twist. If you guys can make a different or maybe harder question, that's and you get a easier question, nothing to lose. Okay, it's a good thing. So always try to expand your question. That's all for me. See you and next video.